Hello, I'm Josh,
I'm Sergio.
I'm Diego.
and we did our presentation for energy sources on nuclear power. We're going to be expressing mostly fission. There are fusion reactors that are under production. We're not going to focus on that because that's way. I mean, we're going to talk about emerging technologies, but that's like way emerging technologies. So here we have a standard design for a fission generator. Here we have where the fuel rods are, and he's going to explain that later on. Which this is basically what's going to be explained in the next slide. It's just how it works in like a visual.
So the first question is what's it classified at? It's a non-renewable resource. And how's it made usable? So uranium oxide is mined, and that's converted into uranium hexafluoride, which is then turned into fuel rods. The fuel rods are used to create nuclear reactions, which then causes a nucleus to split, creating energy. The energy heats up water, creating steam and turning turbines, which then turn generators, and the generators convert that into electricity.
Which is what that visual you saw on the front was. Okay, so there are a lot of the reason why nuclear's power has been so slow to be implemented because it requires a lot of extra infrastructure to go along with it. So you have your normal power plants, which you have your sealed reactor core, which is where you have your fuel rods and your nothing called the control rod, which is used to regulate how much energy or how fast I think it was how fast your fuel decays, because that's what it is, radioactive decay that's producing the energy. So you have to have that sealed, or else you're going to be leaking radiation everywhere, which is bad, and also radioactive water everywhere, which is also bad. Then you have on-site waste storage, which is like what this is, where once a fuel rod is completely used up, or it's called depleted uranium, which is no longer undergoing the same rate of nuclear decay. You basically take that, submerge that in water to make sure that radiation doesn't seek out, because it's only producing what are known as alpha particles, which are just radioactive bits of helium or helium nuclei. But that can't go through water or anything, so you stick that in a lead case, put that in water, so you get no radiation anywhere. Then you also have non-power nuclear reactors, which are used for like research. And you have to have transportation, which is you take your spent fuel rods. This is after it's been sitting in that tank for some time. You stick that in one of these cases, which are like purpose built for handling nuclear waste. That's put on like on a truck, on a train, on a boat, and taken to a nuclear permanent storage site, which is this, where basically what you do is you dig a massive hole in the ground, and then you basically take your spent fuel rods, put those in an additional, I think just like steel drum or lead drum, or maybe lead lined steel drum, and just bury a bunch of those in the desert. That is currently, I don't know where that was. But I can tell you for sure that's probably not in the United States. We're currently not storing permanent storage for nuclear waste in the United States. Or it can also be recycled, and you basically take your nuclear rod, and this is part of the emerging technology where they basically take the waste and are able to use it in another process, which I'm going to explain now.
So, what are emerging technologies that are being produced to improve this resource? Molten salt reactors. They basically allow you to use uranium enriched lesser than what it usually needs to be, but still produce a sufficient amount of energy. And they are able to utilize nuclear waste to drive nuclear power.
That concludes our presentation.
Okay.